In the example here, we can see that the first denominator, there's not much we need to do there, but the second one we can definitely factor. So we'll leave that first fraction as is, but then the second one, hopefully we can see that we can undistribute a 3 from both of those. 3 divides evenly into 9 and 12. So we'll have a 3 on the outside, and then we have a 3x squared minus 4 that's on the inside. And so now when we look at those two denominators, we can see that we have a 3 that overlaps between the two. But even though the first has an x squared and the second has an x squared in a set of parentheses, those are really two unique factors. So I am going to have to multiply this first fraction by 3x squared minus 4 on the top and bottom. And then the second one, we're going to have to multiply by x squared on the top and bottom. So our overall denominator is going to include the 3x squared that we see here, and then the 3x to the fourth minus 4 as part of it as well. So that's our complete common denominator. And so now in the numerator, we have just 1 times this. Well, 1 times anything is just itself. So we just end up with 3x squared minus 4. And then for the second part, it's a subtraction question, so it's going to be minus, and then x times x to the second, x to the first times x to the second gives us x to the third. And so the only thing we could probably do to clean up our answer a little bit, denominator, again, just leave it in this factored form. But the numerator, we should write in least to greatest exponent form. So I'll write it as negative x to the third, and then plus 3x squared, and then minus 4. None of those are like terms. There's no other reducing that we can do or anything like that. We can try to make that look like a 2 there. And so now we've got our simplified answer. In the next one, we again need to factor our denominators. This time both of the denominators are factorable. So for the first one, I've got x in the numerator. I'm going to break this up into 2 sets of parentheses with x as the first piece. I'm multiplying to make a negative 12, so I need one of each. And then I need to have a difference of 1 between my factors. So it's going to be 4 and 3, with the 4 being the negative, since I need a negative x in the end. And then for my second fraction, I can see I've got a 5 in the top, and then I'm going to undistribute a 4. So I've got 4 times x minus 4. And so now I'm ready to look for the overlap between these two denominators. I can see they both have an x minus 4, but then the first one has an x plus 3 in it, which the second one doesn't. So I'm going to need to multiply the top and bottom by x plus 3. And then for the first fraction, it's missing the 4 that the second fraction has. So I'm going to have to multiply the top and bottom by 4. So our denominator then ends up with 4x plus 3, and then x minus 4. And then in the numerator, we've got this 4 times x, which gives us 4x. And then plus, we've got 5 times x plus 3. So we have a little distributing and gathering like terms in the numerator, but the denominator is in a good place. So we've got 4 times x plus 3 times x minus 4. And then up top, we have that 4x out front, plus, and then we've got 5 times x is 5x, and then 5 times 3 is 15. So then our last step is to just gather the like terms up top. So we end up with 9x plus 15 over 4 times x plus 3 times x minus 4. And even though we could potentially do a little factoring of that 9x plus 15 in the numerator, it's not going to lead to being able to reduce with anything in the denominator, so there's no need to. We can just leave our answer as is. For our last example, we have 3 separate fractions, so we have 3 places where we're going to have to look to find the common denominator. And what we can see is that there's no overlap between any of these denominators. So all 3 pieces have to be present in the common denominator, x minus 3, x, and 2x plus 1. That means each of the individual fractions needs to be multiplied by whatever's in the denominator of the other 2. So for example, this 4 over x minus 3. I'm going to have to multiply it by x and 2x plus 1 on the top and bottom. For the second fraction, so 2 over x, I need to multiply it by the other two denominators on the top and bottom. So that's going to be x minus 3 and 2x plus 1. So we're going to have a lot of foiling and a lot of distributing that we're going to have to do, but we'll make it. And then the last fraction, my 5 over 2x plus 1, is going to be multiplied by the first two denominators. So it's going to be x minus 3 and x, again, on both the top and the bottom. So we have our common denominator. We have the denominator, which is going to be x minus 3 times x times 2x plus 1. And so just like on all of our others, we don't need to FOIL that out. But unfortunately, in the numerators, we do have some work that we need to do. So for the first, I've got 4 times x. So really, it's a 4x that's going to be distributed into this set of parentheses. So 4x times 2x is 8x squared, and then 4x times 1 is 4x. So now for the second, I'm going to have to do this in a couple of stages. So first, I'm going to distribute the 2 to each of these. So that gives me 2x minus 6. And then that's going to have to multiply the 2x plus 1. So for that, I'm going to have to FOIL. So 2x times 2x gives me 4x squared. And then I've got my outer is 2x times 1, which is 2x. My inner is negative 12x. So 2x minus 12x is going to give us a minus 10x. We'll go ahead and gather those. And then my last is negative 6 times 1, which is negative 6. But we still have one more piece here. We have to deal with this last fraction. So we have a minus 5 and then x. So if we think of this as 5x that's being distributed, negative 5x that's being distributed here, we're going to end up with negative 5x squared, and then negative 5x times negative 3 gives us a positive 15x. So the trick is, because this is minus, we're distributing a negative 5x rather than a positive 5x into that set of parentheses. So now, again, our denominator is going to stay put. X minus 3 times x times 2x plus 1. And in the numerator, we just have like terms to gather. So I can see I have a bunch of x squareds. So 8x squared plus 4x squared is 12x squared. Minus 5x squared gives us 7x squared. Then I can gather my x's. So 4x minus 10x is negative 6x. And then negative 6x plus 15x gives us a positive 9x. And then lastly, I have one integer here, this minus 6. So we'll have a minus 6 as part of our answer. And so with that, we've done everything that we can on this problem. We're finished after that long and winding road.